Are we good? Okay, looks like it's going. So, transformations. Again, right, this is the umpteenth time we've done transformations. So, nothing's changed as far as describing transformations, right? When x is replaced by 2x, it's a horizontal stretch by a factor of 1/2 above the y-axis, etc., right? All those are still the same. We're now going to do it with the log function. The idea is just to keep on, okay, what do the basic ones look like? So is this with c greater than 1 or with c between 0 and 1? So this is y equals log base c of x where c is greater than 1. And this is y is equal to log base c of x. And I expect you to be able to do a reasonable sketch of one, right? Because if you know the base c, right, then you know that when this is, if that base is a 5, then you know that when x is 5, y is 1, right, and so on. So you can actually find some points on a log graph. Okay, so let's take the function y equals log base 3 of x, and it's transformed to produce each of the functions in the table below. All right? So, do it. You can do this. We've done a million transformations. We've been doing transformations forever. Okay, so here are the answers that you should have gotten. And the last one, the x-intercept, how do you get an x-intercept? You set y to 0. So set y to 0, so -4. Okay, I can't solve this, right? But I've changed it from logarithmic form to exponential. 3, the base, to the exponent -4 is equal to the value x, which will be 1 over 81, right? 1 over 3 to the 4th, 1 over 81. Okay, so your, whatever, your x-intercept is 1 over 81. Okay, questions? So we're good, right? I mean, all you need to say, well, x was replaced by x plus 4, which, you know, we all know. If I gave you your first test to look at again, you'd be looking at it going, how did you get that wrong? You know, right? It's so obvious now because we've gone through it a dozen times, half a dozen times. On the grid shown is a graph of y equals log base 3x. On the same coordinate plane, sketch the graphs of the 6 functions from the table above, label each function. So you've got 3 grids. First one is for g of x, h of x. Second is for b of x and m of x. And here's what g of x is, right? You've got your descriptions sitting there as well. So I would more use the description to graph this stuff. Okay, I'm going to shrink this a bit. Oh, you don't have this? Yeah, because it's beside it. It's on the page. I have it for me, so I know what to do. I don't know what to do. You actually don't have any? You got the letters.
Number 2.
What? Number 2, g of x. Okay? Graph this and this on the first grid given. Graph this and this on the second grid given. You do have 3 grids, right? Yeah. Okay. So just do an HS by T. You've got all the stuff, right? You know the equation of your asymptote. Sketch in your asymptote. You know your domain. You know your x-intercept. It's log 3x. You can do other points, right? Let's do that one together. So here, we'll do this one in red. Log 3 of x over 2. So it's a horizontal stretch by a factor of 2. Intercept's the same, yeah. So it goes through 0, 2. Okay, what do we know? We know we've got the point 3, 1. Where is that going to map? It's going to go to 6, 1. Right? We've got the point 9, 2. Yeah, okay, that's way out there, right? So we can't do that. Okay, now we can do this guy in green. Okay, so you have 2 points on this graph that you know, right? You know 3, 1, right? Log base 3 of 3 is 1, log base 3 of 9 is 2. So you have the point, this point you can work with, and this point you can work with. Now we couldn't do anything with this because horizontally stretching is going to throw it way out to the right off the grid. But Vertical stretch by a factor of 2, 9, 2 goes to 9, 4. 3, 1 goes to 3, 2. 1, 0 goes to 1, 0, right? Because it's on the line of stretch, so it'll be invariant. Okay, and then this goes down. And we'll do the same thing with these guys. And again, you can look back. You've got this, so you've got your characteristics there. You know, which way do I open? Where's my X-intercept? Okay, so reflection of the X, so that's there. That's there. Okay, and what's that? Reflection of Y action. There. That's there. Okay, so there's those two. Bless you. And one more. P at X and R. So that's right, that's going left. 1, 2, 3, 4. Not the greatest, but still. I expect better from you. You have erasers. But show points, right? So you want to put down all the points that you can. So you know on this graph, you basically have 3 points. You have the point 1, 0, right? Which is on every log function, no matter what the base is. You have the point, now for base 3, you have when x is 3, 3 to the what gives you 3, 1, and when x is 9, you have 2. So you've got the points 3, 1, and 9, 2, and all you're going to do is what the mapping says, right? Move them left 4, move them up 4. Okay, whatever the particular mapping is. All right, so I'll just bring these back again. You can take a look at these two guys. And this is also online, right? You've got the answers are online. I'll make sure that they're up. And then here's these two guys, right? Left 4 and up 4. Okay, what affected the range? Did any of them affect the range? So if you look through your range column, did it change? Right, because it's all real numbers, so really what can you do to affect the range? Nothing, right? You vertically stretch by 2, it affects the y value, but it's not going to change the range. So, no. List the only transformation. It's only one affected the vertical asymptote. Which one was it? So the horizontal translation, which went left 4. Okay, so you think about the asymptote is at x equals 0. Reflecting about that line won't change that asymptote, right? What else? Stretching about that line won't change that asymptote. The only way it's going to change is through a horizontal movement, right? Horizontal translation, really. List the transformations that affected the domain. Okay, so which transformations? So you just go down to your list, say what changed the domain? It should be x is greater than 0, but so horizontal translation, and what else? So the reflection was the first one. So reflection in the x-axis will change the domain, and the horizontal translation. Okay, left 4. Reflection in the y-axis. Yeah, sorry. And horizontal translation left 4. So a horizontal translation or a reflection in the y-axis will change the domain. Okay? State the domain for each of the following functions. So how do we get the domain? What do we know about the argument that's given to the log function? It's got to be positive, right? So we know the argument. In this case, the argument is the thing that's in the square bracket, or the thing that's you're doing the log of. It's not the -2 here, right? It's the, in this case, it's the 2 times x plus 5 has to be greater than 0, right? You cannot take the log of a negative. It must, and you can't take the log of 0 either. So x plus 5 must be greater than 0, dividing both sides by 2, and x is greater than -5. Okay, we do the next 2. Another way to look at this, you could just say it goes left 5, right? So it just goes left 5, it's going to be greater than -5. This goes which way? Which way, how much? Ah, you factor out the 3, right? Remember that, we've been caught enough times by that. So it goes right 1. Okay, so it was x is greater than 0, now it's x is greater than 1. Okay, again, you can also do it as 3x minus 3 is greater than 0, 3x is greater than 3, x is greater than 1. You can say it moves right 1. Right 1, x is greater than 1. This one? Okay, so you guys say, well, it's reflected in the y-axis, and then it's moved. Well, wait, okay, we can't do this without factoring it out, right? So you'd write negative x plus 4 if you want, and then negative x minus 4. So we've got a reflection. Now, this might be easier to just go 4 minus x is greater than 0. So you say negative x is greater than -4, or x is less than 4. Okay? That's probably the easier way. Otherwise, you're looking at this and saying, well, so x is x minus 4, that's got to be, so 4 minus, 4x is greater than 4, but then it's reflected, so x is less than 4. Okay? I like this, it's easier, I don't have to think about it. Oh wait, it's reflected, and it's, just say, hey, this has to be greater than 0. In general, if y equals log base c of x is transformed to, so you can see everything's over on the right-hand side, right? So looking at this, we say it's no different than if it was a radical, it's no different than a rational, it's no different, right? All of these things that look, even sign, A sign, B bracket. Now we use different letters, but it's all the same idea. So what's the equation of the blank asymptote? What kind of asymptote do we have? The vertical asymptote is what? What affected the asymptote? The only thing, the horizontal translation. So what have we gone? So it's x is equal to h, right? And the range is? The log function, the range is always y is an element of the reals. If b is greater than 0, the domain is? So if b is greater than 0, we have no reflection in the y-axis, right? But what's happened? It's still moved. Greater than 0, but now it's moved. Where did it move? So it's greater than h, right? Because it's moved to the right h unit. So x is greater than h. If b is less than 0, then the domain is? X is less than h. Okay, so x is less than h. Okay. You have a reflection. If b is less than 0, there's reflection. Since you can only take the logarithm of a positive number, another way to determine the domain is to find all the values of x for which b times x minus h is greater than 0. It ran out of ink. Greater. Yeah. It ran out of virtual ink. So you could say b times x minus h must be greater than 0. So x minus h must be greater than 0, right? You divide both sides by b. And x is greater than 0, okay? That's if b is positive, right? Because, I'll do it over here, so b times x minus h is greater than 0. X minus h is less than 0. That's if b is less than 0, right? Because then you're dividing both sides by a negative. You have to change the inequality sign, and so x will be less than h. Okay? It's just summarizing stuff.
Why would x need to be greater than 0? Wouldn't it be greater than h then? Because if you add h to both sides, or am I missing something? No, on the other one.
This one?
Did I just miss something?
Yeah.
Oh.
You missed telling me a minute ago. That should be an h. Somehow I got the h out of there. Yeah, so it's you're not missing anything. I am missing things. Okay? So if b is greater than 0, you're dividing both sides by a positive. We do not change the inequality sign. X is greater than h. If b is less than 0, it's a reflection in the y-axis. But you don't need to think about that. You can just say I'm dividing by a negative, so it's less than. So change the inequality sign. X will be less than. A log equation given by 3 log base 2 4 minus x. Algebraically determine the x-intercept. So how do we get the x-intercept? Set y equal to 0, right? So set y equal to 0. So we could say 0 is equal to 3 log base 2 of 4 minus x. Okay, go ahead, solve that. I don't know what to do with that, but I know I can change it to an exponential form, right? So that I can say what? The base 2 to the exponent 0 is equal to 4 minus x. 2 to the 0 is 1. Subtract 4. So there's your x-intercept, right? X is equal to 3. That happens, you get 4 minus 3, which is 1. Log base 2 of 1 is 0. 3 times 0 is 0. Y is 0. Verify your answer with the GDC for you to do. Next, the graph. Of y is equal to negative 6. Log base 1/3 2x is the graph of y equals log base 1/3. Blank stretched by a factor of, okay, you pick. Horizontally stretched by a factor of, horizontally by a factor of 1/2 about the y-axis, and vertically stretched by a factor of 6 about the x-axis, and then about the x-axis. Right? So instead of log base 1/3, you could have seen an f there, f of x, we'd just be talking about f of x, and you're like, we've done a million of these now, right? Okay? Easy to do. We should not be able to show you any transformations. You just can't look at it and just throw those words down now, right? The graph of y equals log base c of x is vertically stretched by a factor of 3, horizontally stretched by a factor of 1/2, reflected in the y-axis, translate 1 unit left and 4 units up, write the equation in the form, give it a shot, just write it. Okay? Don't go through any steps, just write out the final answer. Okay. By now, you should be able to do that. If you can't, let's find out, and then you'll know, okay, when I do this, I got to show more steps. Okay, let's give it a shot. See if you can write it out directly, final answer. If everybody gets it, we'll just move on, right? It's like, good. All right, what's going on here? I need that, so that's that. Okay, it's just log base C, right? That's the function. What am I missing? Oh. Mismatched parentheses. You do that. Various computer programming languages, you mismatch your parentheses, things are just not going to work and you won't know why.
Even if they do work.
Yeah, and if they do work, it's going to do something strange, right? Okay, so is that what we got? Everybody get that? Yeah? Okay. Everybody good? Nobody needs to see step by step? Okay. You can do it step by step, right? You go y over 3 is equal to log base c of x, which you could then move the 3 out front there if you want y equals 3. Okay, horizontally stretched by a half, so you're 2x, then it becomes negative 2x, then it becomes negative bracket 2x plus 1, and so on. Okay. So we're at the stage where by now you should be able to take all of that, just write that straight out, okay? But you need to be comfortable with doing your thing your way, so if you need to write out each one separately, feel free. But that's where you should end up. Graph y equals log base 3x is transformed to the graph of y equals negative 9 log base 3x plus 1 plus 18. Describe the transformations in the correct order. Go for it. I'm going to post to our viewers at home, so this is what you should have come up with, yeah? So what affects the asymptote? What's the only thing that affects the asymptote? Horizontal translation. Where do we go? Left 1, what's the equation of the asymptote? Okay, so x is equal, running with the wrong side of the pen. What's the range of every logarithmic function? Y belongs to the real. What's the domain? X is greater than negative. Well, wait a sec, but it's that's a reflection in the x-axis, not the y-axis. Okay. Remember, all you're doing is saying this, right? X plus 1 is greater than 0. It's this thing here. The argument to the log function has to be greater than 0. Okay. What's the y-intercept? How do you get the y-intercept?
Log 3, 1 is 0. Everything is 0 plus 8. Just 8 plus 18, that's the y-intercept.
Okay, so log 3, 1 is 0, right? Log base anything of 1 is 0. So negative 9 times 0 plus 18 is just 18. What's negative 9 times 0? 0 plus 18, still plus 18. Okay. How do we get the x-intercept? Set y to 0. Okay, so subtract 18, both sides. Divide both sides by negative 9. And then say, I can't do this. Yeah, I can't solve that, but I can change it to exponential form, which says 3 to the power of 2 is equal to x plus 1. X plus 1 is 9, and x is equal to 8. Okay, so that's your x-intercept, right? 8. Verify the information with the GDC left for you. Like left 4 units. Could be a horizontal translation. It's something you do on your own. The mapping shows transformations were applied to any function in the world as far as part A goes, right? So the fact that it's log base 2x doesn't actually come in until part B, right? This is just, here's a mapping of a function. Describe the transformation. It doesn't have to be log. It could be f of x. It could be the sine function. It could be anything, right? This is just a mapping. So describe the transformations in the correct order. So I'll give you a hint. There's 5 of them. Okay. Okay, so is that what we got?
Yep.
Okay, vertical stretch by 3. So remember, mappings do exactly what they say you're going to do. You multiply y by 3, you've got a vertical stretch by 3. That's not a surprise because when you go y equals, you put the 3 on the other side. When I take a half of x, it's a stretch by a factor of 1/2. Right? When I take negative 1/2 x, it's then reflected about the y-axis. Okay, what's the image point? So we can trace this out, right? So when I apply transformation number 1, which was what, vertical stretch by a factor of 3? Then I apply transformation number 2. And then 3. And then I'm going to do 4 and 5 together because I'm running out of room. And what is it? Left 1 and up 5.
Actually, you did it right. I forgot the reflections. I forgot the reflections.
She did it right, or she did it right?
We erased it. Yeah, that's why I made Oh, that's why. I just did the math.
Or you could just do the mapping,
Yeah.
as was said just prior to me. So it's negative 1/2 of x. What's the rest of the mapping? Where'd it go? Minus 1. Oops. Minus 1, comma, and then 3 times y plus 5. So negative 1/2 of 8 is negative 4 minus 1 is negative 5. And 3 times 3 is 9 plus 5 is 14. Okay? So if you have a mapping there, it just tells you how to get to the new point, right? Plug in the old point, I'll give you the new point. Okay, now it becomes, now we're going really specific to the function log base 2 of x. Write the equation of the transform function. Your choice. You can do it a step at a time, or you can just say, I got it, I can handle this, I can write it all out at once, and just write it all out at once. So looking at my things, I've got a 3. Okay, what form do I need? A log base 2. Negative 2. So. And we're doing 5.
Oh my gosh.
Okay? So the number in front is my vertical stretch, and if there's a reflection in the x-axis, which there isn't. Horizontal stretch, leave some space so there's a reflection. So horizontal stretch by 1/2, you got a 2 reflection. Left 1 for the x plus 1 in bracket, and up 5 plus 5 on the end. Okay? Verify the equation using the image point from part B. So that basically says the image point is negative 514.
Why different? They moved it to the right. By taking away the
Oh, it's disappeared off. So. Yeah, I didn't write that at first. Okay, so the image point has an x value of -5. We expect to get out a y value of 14. That's the equation we think is going to give us. So if this works, we should get a value of 14. Okay, so all we got to do is just evaluate this. Y is equal to 3 times log base 2. So that's -4, +8. Log base 2 of 8 is 3. And y is equal to 14, and that checks. That's the value we expect to get out, right? So it's -2 times -5 plus 1. -5 plus 1 is -4 times -2 is +8. That value has to be positive. You cannot do log base 2 of a negative. Okay? Log base 2 of 8, 2 to the what gives me 8. 2 cubed, 2 to the 3. 3 times 3 plus 5 gives us 14. State the domain of the transformed function. So what changes the domain? This and reflection in the y-axis. Okay, so what does it become? X is less than -1. In interval notation, it would be -infinity to -1 with parentheses. Okay, no brackets, because it's not equal to -1. Okay, you've been such a lovely audience, and we have some more time, so let's move to the next page. You'll see your test. I'll get you started. So, here's the deal. Investigating. You need to be the investigator. So you're mostly going to do this tonight. Investigate. So, if you look at these, what's log base 2 of 2? Log base 2 of 4? So what I want you to do is, using that table above, fill in this table, fill in these numbers, check these statements, and come up with the sum of the logs of two numbers. Okay? Let's just do this line here. What's log base 2 of 2? 1. What's log base 2 of 32? What's 1 plus 5? 6 is equal to log base 2 of what number? You just got to look up here, right? 6 is log base 2 of 64. Okay? So what you're looking for is, what's the relation between this and this? What's the relation between 2 and 32 and 64? Multiply, right? So what's raised to it be 4 and 8 and 32? 4 times 8 is 32. Okay? Here's your rule. State the value of each of the following. Well, that's probably not even on your sheet because it's just a different. But then you do the difference of logarithms. And you discover the next law. And then, okay, let's take a moment. We'll look at this. Those first two laws are pretty easy. Determine the log of a power. So log base 3 of 2 to the 5th. So if you think about what does that mean? It's log base 3 of 2 times 2 times 2 times 2 times 2. It's repeated multiplication. You are going to discover the law for multiplication, which is that if you have a product, you split it out as the sum of individual logs. And in this case, we have 5 of them. Okay? And then you discover the power law. Oops, going backwards. Okay. So, investigating the laws of logs. is for you to do, because it really is an investigation, right? You're supposed to come up with like whatchamacallit, learning by doing, right? And then tomorrow we will actually start on the laws of log. We'll take a quick moment to just go through this. Okay, so tomorrow we'll go through investigating the laws of log, make sure everybody's got the correct answers for it, you've made the right observations, and we will move on with the laws of logs, okay, using them.